You know, we hear the word steel all the time. It's in our cars, our buildings, the very knives in our kitchens, but that one simple word, it hides this whole universe of different materials, each with its own secret recipe. The real story of steel is, I promise you, way more fascinating than you might think.
So, just think about this for a second. How is it possible that the same basic material can be used to make the massive, rugged beams of a skyscraper and also the tiny, delicate, razor-sharp edge of a surgeon's scalpel? I mean, those two things are worlds apart. What is the secret here?
Well, the answer is, it's not one material at all. Steel is more like a family name for over 3,500 different grades. Yeah, each one is a unique recipe, custom designed for a very specific job. That's a huge library of materials to pick from.
Honestly, the best way to wrap your head around this comes from a Reddit user who said, making steel is a lot like baking. You start with a basic dough, you add different ingredients, and then you bake it in a very specific way. And that combination, the recipe plus the process, that's what decides if you end up with a hard, crunchy cookie or a soft, fluffy cake.
Okay, so let's start with that basic dough. At its heart, every single piece of steel is built from just two fundamental ingredients.
The foundational recipe is just incredibly simple. You take iron and you add a little bit of carbon. See, pure iron on its own is actually pretty soft. The atoms can just slide past each other really easily. But when you mix in those tiny carbon atoms, they kind of wedge themselves into the iron structure and make it way harder for those atoms to slip. That's what gives steel its famous strength.
And you can see right here just how powerful that one ingredient is. Just by tweaking the percentage of carbon, you completely change the end result. Low carbon steel, it's soft, it's easy to shape. High carbon steel, that's incredibly hard. It can hold a sharp edge, but it's also a bit more brittle. And right in the middle, you've got medium carbon steel, which gives you a great balance of both.
And what's wild is that this simple iron and carbon recipe, well, that makes up about 90% of all steel produced in the world. Because it's so strong, so reliable, and pretty cheap to make, it's become the absolute workhorse of the modern world. We're talking everything from I-beams in buildings to the body of your car.
All right, so we have our basic dough down. Now let's see what happens when we start adding some special ingredients to the mix. This is where we really start to see those 3,500 different grades come to life.
These special ingredients are called alloys. And in our baking analogy, these are like the chocolate chips, the spices, or the nuts that you fold into the dough. By mixing in other elements, engineers can fine-tune steel's properties for really specific jobs. Think of this as the spice rack for making steel. You want to stop rust? Add some chromium. Need it to stay strong in extreme heat? Mix in some tungsten. A little bit of nickel as toughness so it won't shatter if you hit it. Every single element brings a unique and predictable quality to the final product.
And here is where you see it all come together. On one side, you've got your basic carbon steel. Strong, cheap, perfect for a building. But add about 10% chromium and boom, you get stainless steel. All of a sudden, it's super resistant to rust, which makes it perfect for your kitchen sink or sterile medical tools. One ingredient, a totally new purpose.
But listen, the ingredients are only half the story. Just like with baking, it's not just what you put in the bowl, it's how you cook it. And the baking process for steel, which is called heat treatment, is every bit as important.
We can break the whole process down into two main steps. First, you heat the steel up to a really high temperature. This makes all the atoms inside rearrange themselves into this uniform, kind of liquidy structure. It's like stirring the batter to make sure everything's mixed in. Then, you cool it down. And the speed of that cooling process is what locks the atoms into a brand new crystal structure.
This final atomic pattern is called the microstructure. And you can think of it like the crumb of a cake or a cookie. You know how you can just look at the inside of a cake and tell if it's light and airy or dense and heavy? Well, it's the same idea. The microstructure is steel's atomic fingerprint, and it's what ultimately defines all its important properties.
And this is the part that just blows my mind. The cooling process is so powerful that you can take two pieces of steel with the exact same chemical recipe, cool one down slowly, and then dunk the other one in cold water, and you will end up with two completely different materials with different grades and different properties. That's amazing.
So, with thousands of different recipes and all these different baking methods, how in the world does an engineer pick the right one? How do they make sure the steel for a bridge is the exact same every single time?
Well, the answer is standardized grading systems. Organizations like the Society of Automotive Engineers, or SAE, have created what's basically a massive global recipe book. A simple 4-digit code, like 1060 or 4140, tells an engineer the exact ingredients and amounts. It ensures that steel made in one country is the same as steel made halfway across the world.
This table really ties it all together beautifully. For a construction beam, your top priorities are low cost and high strength, so you go with basic carbon steel. For a kitchen knife, you need it to fight rust and hold a sharp edge. That's a job for stainless steel. And for something like a jackhammer bit, you need crazy toughness and shock resistance, so you use a specialized tool steel. It's always a trade-off, a balance of properties to find the perfect recipe for the job.
So, next time you think of steel, don't just think of one material. Think of this massive, adaptable library of over 3,500 different recipes. Every single one is a unique mix of ingredients and baking instructions, perfectly customized for its purpose. And that's how you get from a skyscraper all the way down to a scalpel.
And that leaves us with a final thought, right? Steel has been with us for centuries, and yet we're still finding new ways to perfect it at an atomic level. It just makes you wonder, if this is what we can do with a classic material, what will the brand new materials of the future look like? And what incredible things will they let us build?